Hello, the Unretired Engineer coming at you today with some interesting info and thoughts regarding bigger picture of engineering projects and human nature. So the chart that you're seeing now talks about two numbers that I think are very critical, which is terawatts per hour, number of deaths. So number of deaths per terawatt hour. So if you look at that, hydropower is 1.3 deaths per terawatt hour, and nuclear is 0.03 deaths per terawatt hour. That is a huge difference, and it is not the story that you hear. But you also look at solar, and you see that it is down there with nuclear, right? So nuclear and solar are both very clean, and hydro is supposed to be another very green technology, and yet it has a much higher death per terawatt hour. There is a tragic story behind that, and it's very interesting when it points to some of the issues with human nature and why we went away from nuclear. So again, if you like this kind of information from an engineering viewpoint, and a lot of years in industry and looking at human nature, please hit the like and subscribe, and feel free to hit the comments. So talk. So this is the other piece of the story and why hydro isn't down there with nuclear and solar at the deaths per terawatt. In August of 1975 in Henan province, there was the Banqiao dam. The typhoon Nina, roughly a year's worth of rain in 24 hours, and the dam was overtopped. And then when that dam failed, 62 reservoirs failed in sequence, and a wall of water 6 meters high, 10 kilometers wide, running at 50 kilometers per hour, killed directly 26,000 people. And over the next year, because of food and other disruptions, famine and disease, basically killed at least another 170,000 and maybe over 200,000 people. And yet, we've never heard of it. Yes, the Chinese government hid a lot of this and never raised it. But it was known, and nobody stopped building dams. There was no freeze, no moratorium. Even though there had been other dams, there have been other dams that failed, and those dams have killed thousands of people over time. And yet there is no moratorium on building dams. So, you know, this is kind of the direct comparison with that, right? So you have the first famous reactor problem, 3 Mile Islands in 1979, a partial meltdown. But the containment system, which had been designed in, worked. There was 0 deaths, and there was very little contamination in the outside world. There was a little, and you could see steam coming off of the pressure vessels. And that was made into a huge deal, but it never resulted in any appreciable increase in cancer or anything else in the world. So what happened? Basically, the regulatory regime clamped down because it was used as a flail against the industry and against the technology in general because of fear. Then you have Chernobyl in 1986. It was a known flawed design, and it was operated way outside of its operating envelope in an insane manner in many ways. So, you know, and then so it failed. It caused a massive outflow of people because the area was contaminated. But as far as anybody knows, there were only 30 direct deaths, and those were mainly people who sacrificed themselves in the early hours and days to make the site safe. And they think somewhere in the order of 400 people may have died because of other things, but everybody expected a massive increase in cancer deaths and other things, and that never occurred. It's one of the things that continues to indicate that the threat of nuclear contamination has been way overstated forever, essentially since the very early days of the technology. So, and then you come to Fukushima in 2011. It was an M9 earthquake and a 15-meter tsunami killed 20,000 people and knocked the reactor out. There's no denying that the reactor had not been designed to withstand that and failed in ways that probably could have been predicted. But nobody really ever expected it to have to take that heavy a hit. But at the same time, the number of radiation deaths is zero. That is proven. There was zero radiation deaths. The deaths that were basically attributed to it, which is 2,300 deaths, were all to do with the evacuation. They were basically people who were already sick, who had to be evacuated in a chaotic environment. Chaotic more because of the earthquake and the tsunami than the nuclear. And they died because of knock-on effects for that. There have been some very extensive studies, and people have looked at this, and the number of deaths that were directly attributable to Fukushima is only 2,300, and none of them had anything to do with radiation. So, what was the result? Well, Germany had already started their process of shutting down their nuclear plants, but they used Fukushima as a flail to basically immediately shut down their nuclear power plants and drive themselves into economic chaos, and chaos that they have yet to even really begin to come out of. But, counter to that, right? So the thing that a lot of people don't really even think about is that coal deaths per terawatt hour are 24.62. That is 3 orders of magnitude above that for solar, and close to that number above nuclear. And so the issue is that the mechanism of death is totally statistical. It is particulates in the air, lung disease, emphysema, all of those things. So it is very clear that has been a problem. Modern scrubbers and modern plants have nowhere near as much problem, and most plants today are very clean. They still have a lingering effect because those scrubbers are of relatively new provenance. The damage done in past years is still there. And there are still plants out in the second and third world which have never been remediated and still causing deaths. But, the thing is about coal is, there's no headline, there's no evacuation zone, and nobody is talking about shutting down those plants, except maybe the Germans, to save all those lives, because nobody can conceive of modern life without electricity. There is no modern life without electricity. It's known as dread risk. It's invisible, involuntary, catastrophic association. So it's essentially that the issue is that human nature is such that we accept risk within our environment. We all drive. We all know it's dangerous, right? We all know that people who have been hurt, been killed in automobile accidents, and yet we continue to do it because it's something we recognize, we value the ability to do it, and we move on. It is the same as with the risk with coal, right? We value what we get for it, and the risk is so low that it's background, and in the case of coal, it's not really visible. It's not irrational. It just is the way it is. If you see something like a nuclear thing where essentially it's associated with weapons, right? So associated with mass death, even though a nuclear power plant has no direct correlation to a nuclear weapon, it's associated. That was driven into us in the 1950s, 60s, 70s, and whatnot, and sometimes somewhat purposefully to make us afraid. And the thing is nuclear is a hidden killer, right? It's a little bit like coal dust and particulates in the air, but the thing is we all hear about it, we know about it, we can measure it with a Geiger counter, and so it drives fear. So the thing is that because of that dread risk, it is easy to functionalize that and mobilize people about the risk. And so it has been done for many different reasons, and helped to drive nuclear off the table as a viable option for multiple decades. Fortunately, that's beginning to change, but it is still an interesting mechanism in that we are very afraid of things which are immediate and obvious and driven, and things that are a continuing background risk, even though higher in total, we tend to totally discount. On the nuclear side, from a viewpoint of an engineer, one of the things is there's the thing called the regulatory ratchet. And essentially, a ratchet is a device that allows you to go in one direction and will never go back in the other direction. And this is one of the key issues always with regulation of any sort for anything, is that once a regulation is in place, it is almost impossible to get it off the books. And so what happens is something will be regulated, click, and then it'll be regulated again, click, click, and then something else, click. And every time it makes the job harder. The other problem is most of the time when it's a regulator, they will say, I don't care that it's costing you extra, that it's changing your plans, do it anyway. Essentially, they are not bearing the cost of that, so they are essentially driven by the common good, and they will then drive forward with their regulation. So that essentially is one of the mechanisms, the primary mechanism really, that destroyed industry in the United States, is that things like cable separation and things like that, they would be implemented and say, yeah, well, you haven't finished building your your plant, you need to implement that. Well, I've laid miles of cable. No, okay, fine, rip it all up, put it new in. And the problem is when you're an engineering project manager, you have no idea if the next where the next regulation is going to come, what it's going to cost you, and you build those regulatory risks into your risk registry and you put a price on that, drives the price up, but the next thing you know is something else hits you and you drives the price up even more. It makes investment literally impossible in this environment, and that is weaponized essentially to drive industries that people are against, to drive those industries out of the market. So just leave this thought. 0 people died in TMI. The containment worked, but essentially it became impossible to build new plants, even though those new plants had learned vastly, they were more modern than the TMI plant, and there were new things that could be done and were always being done and implemented, but it became impossible to build a new plant because the regulatory environment never settled down, and it became functionally impossible to build those plants. So deaths per terawatt hour is a very easy metric, and it's consistent across methodologies, and it will give you kind of very quickly a snapshot of what makes sense really from the human scale. The problem is that it doesn't matter. That dread risk is really the problem. Even though nuclear is way under any fossil fuel, even the cleanest, which is natural gas, which is very low, it's still treated essentially as something which is dangerous. Hydro, which is because of that one disaster, is significantly higher than nuclear and PV and wind. And again, nobody has ever considered shutting down hydropower, even though hydro, dams, etc., have failed in the past, will fail in the future. And oh, by the way, also do run out eventually. They silt up and then have to be either dug out or usually just replaced. And so, sometimes people don't realize that, a dam is not forever. But again, human dynamics drive this. The data doesn't really matter in a lot of these cases. And then the data in the hands of people who want to use it in certain ways allows them to twist the story in ways that are advantageous to whatever they want to do. But the question is, where is this dynamic yet working? Are there other things that we're doing today which we're already limiting, when the reality is it could easily be a better solution, but it's demonized because it has some element of risk that triggers our monkey brain. So I'll leave you with that one. This is the Unretired Engineer, and have a great day. Cheers.